All right, so we're going to take a look at section 9.2. Okay, 9.2 is on solving ratios and proportions. Okay, so it's solving equations. Equations similar to the kind you've seen before, but you're going to learn a new technique. Okay. First, let's look at the idea of what a ratio is. Okay. A ratio is when you compare two numbers using division. Okay? So let me show you an example with a recipe. Let's say you had a recipe that said for every 3 cups of flour you use, you need 2 cups of water. We could come up with a ratio of flour to water. In this case, it's a 3-to-2 ratio. Okay? That's an example of a ratio. Every 3 cups of flour, you do 2 cups of water. Right? So a ratio, you're comparing 2 quantities. Okay. Any question on the idea of a ratio? Okay. Sometimes we see a ratio when we write speed. Miles is in the top, hours is in the bottom. Miles per hour. It's how many miles we cover every single hour. This is how many cups of flour we use compared to how many cups of water we use. Okay. So when we take 2 ratios, okay, 2 separate fractions, and we set them equal to each other, we get what's called a proportion. Okay? This is an example of a proportion. You have a ratio on the left, which is a fraction, a ratio on the right, which is a fraction, and usually there's a variable somewhere. Okay? That's a proportion. How many people have seen proportions before? Okay, so most of you might be familiar with this. The 2 important things you need to know in the proportion. Okay? A and D, these 2, have a special name. Okay? Those are called the extremes, okay, of a proportion. A and D are called the extremes. Okay, on the test, I will give you a proportion, and I'm going to ask you, what are the extremes? So it's the 2 that are on that diagonal. Okay? On this diagonal, the B and the C, those are called the means. Okay?
So guys, I would strongly suggest, and I bet Mr. Hager would too, you want to at least write that down. In the proportion, write down A over B equals C over D. A and B are the extremes, C and B are the means. You're going to want to have that somewhere in your notes. You may want to put it on your study guide tonight. Because like Mr. Hager just said, you're going to be asked to identify that on the test tomorrow. It involves no math. You just have to write down what they are. That's an easy 5 points if you have that stuff in your notes.
So looking at that proportion up above, what are the extremes in that proportion that I put in the box? Isaiah?
7 and 3.
7 and 3, good. What would be the means? Someone else? 2 and X. That's it. Okay? We're not solving it yet. There's an answer to this problem. We could solve it. For now, I'm just having you figure out what are the means, what are the extremes. Any questions on how you identify that? Okay, everybody has that written down. Okay. So, well, we just did this. Let's write it down. So, means, extremes. Okay, what did we say the means were here? So in this example,
Wait, do you want us to write down the whole example?
yep, this is example 1A.
7 and 3.
7 and 3. Okay, so your means go from the upper right to the lower left. Let's try again. What are the means? No, 7 and 3 are the extremes.
Write example 1. It goes back
Oh,
to
the means.
X and 2.
Okay. So my means are X and 2. Okay. Now the extremes. Those go from the upper left to the lower right.
7 and 3.
Upper left to lower right. 7 and 3. Okay. Just one of those things you have to remember. Just try to memorize it. Okay, any question on that? Means and extremes. All right, now let's solve that. Okay, how would you solve that proportion? How would you get x by itself there? There's only one thing you have to do and you're done. Yeah?
Multiply by 3.
Perfect. Let me do it over here. So we have 7 over 2 equals x over 3. We're going to multiply both sides by 3. So your 3's cancel. Now 3 is not a fraction, but how could we make it a fraction so we can do that? Put it over 1. So what is x equal to? 21 over 2. Very good. 3 times 7 is 21. 1 times 2 is 2. Right? Any questions on solving that?
Yeah,
So we multiplied both sides by 3. Okay? Nope, we're going to get to that though. So we had an equation where you had a 3 in the denominator, you're dividing. What's the opposite of division? Multiplication. What are we dividing by? What number did we have here? 3. So to undo that, we're going to multiply by 3 on both sides. Okay? And what that does is that cancels the 3's out and leaves us with 3 times 7 is 21 over 2. Okay, let's try another one of those.
I don't listen.
Identify the extremes and the means, and then we're going to solve it. Okay, let's start off with the extremes. What are the extremes here? Yep, Dominic? X and 5. Extremes always start in the upper left, okay, and they go to the lower right. Those are your extremes. Good job. What are the means here? Yep, Laura? 4 and 9. Very good. Okay. Now we're going to solve it. Okay. So we have x divided by 9 equals 4 over 5. Okay. What have we done to x on the left-hand side? Right now, what have we done to it?
Nothing.
Well, something's been done to it because it's not by itself.
Put it with 9.
We've divided it by 9. So we have to undo dividing x by 9. How do we do that? Multiply by what?
9.
By 9. And how do we make 9 a fraction? Over 1. Okay. That's going to cancel on the left. What do we have on the left-hand side now?
Just X.
Just x. How about on the right-hand side? Yep, and what does that simplify?
45 minutes.
Yep, 9 times 4 is 36
45.
over, slow down, 4 times 9, 36, 5 times 1. 5. We're not doing any kind of cross multiplying yet. We were just multiplying fractions straight across. Okay, so I'm showing you that you guys already know how to solve basic proportions. Okay, ones that are set up like this. Okay, a couple people mentioned the idea of cross multiplying. Right, that's a technique that we're going to use to solve. Well, we can use it on basic ones, but we can also use it on more complicated ones. Okay, so cross multiplying, if you know how to do that, that's what we're going to look at right
Hey
now.
guys, you get, for the cross multiplying, you get the same thing. All right, same exact thing.
Okay, so cross multiplying, or if you look it up in your book, it's called the proportion property. So if you have a proportion, just like that, okay, A over B equals C over D. Keep in mind, B and D would never be 0 because you can't divide by 0. So I guarantee I'll never give you a problem where B or D is 0. Then when we cross multiply, the extremes, A times D, equals the product of the means, B times C. Okay, so that's where you might have seen cross multiplying before. Okay, how many people have seen that before? Product of the extremes equals the product of the means. Maybe you didn't use.
Just do that.
Nope, we didn't just do that. We used our basic properties of equation solving before.
Is that cross multiplying?
This is like cross multiplying, yep,
So like butterfly or whatever you want to call it.
sure. So we're going to use this property to solve some equations, okay?
Yeah.
Everybody have that written down? A times D equals B times C.
This guy's just that's this cross multiplying, right? This you're multiplying by what's opposite. And I think a lot of you guys asked on the last couple we did if we could cross multiply. And Mr. Hager said you could have, but we weren't at that point yet.
Okay, so now we're going to solve some proportions where we cross multiply. Okay? The technique that we used before, it worked because it was a simple proportion. When we get into ones that are more complicated, we're going to have to do it this way. Okay, we're not going to have a choice. Like this one. Okay, it says 2 divided by x equals 3 divided by x plus 6. Now, on this one, you can't really do it the way we did it before because we got variables in a couple spots. Okay, and I want you to notice something right away. Okay?
We talked about this last academic week.
Not yet. We don't have like terms yet. But look at this denominator. Does it have more than one thing in it? Yeah. What's it got? It's got an x and a 6. What's the first thing you should always do when you have a denominator that has more than one thing in it? Nope.
6x.
Okay, let's think about when we multiply, we're going to multiply on the diagonals, right?
Yeah.
The 2 is going to get multiplied by what?
2x plus 6.
Oh, it's going to be x. And then it'll be multiplied by 6.
It's going to, the 2 gets multiplied by the x and the 2 gets multiplied by the 6.
Distributive.
So it's a distributive property. A lot of people forget to distribute. Okay?
2x plus 12.
So, yep, my suggestion is right away, put it in parentheses so you don't forget to distribute. Okay? Now, what were you guys telling me? What's 2 times x plus 6?
2x.
Good. Now, is there a distributive property on the other diagonal?
No.
No. Just a basic x times 3. Okay, what's x times 3?
3x.
3x. So we did the product of one diagonal equals the product of the other, but don't forget to distribute if you need to. Any question on that? Yes?
Are we solving this?
Now we're going to solve. Okay. So now we can use our basic steps we already know. What's my next step to solve for x? Actually, it's my next step and my last step.
I have a question.
Yep.
Is this stuff going to be on the test?
Yep. You're going to have 5 of these on the test
Should we
tomorrow.
write down these examples?
Yes. Yep. Anytime that has an example with a number, you need to write it down.
Oh, are you giving us the things today?
Yep. I'll do that at the very end of class.
So you subtract 2x,
Yep. Subtract 2x. Subtract 2x.
1x, and then
So now, yeah, your 3x minus 2x is just 1x. What's on the other side? 12. So as long as you know how to use your basic equation solving, bringing the x's to the other side, you're done. X equals 12. Okay, let's try this one. It says 4 divided by a equals 6 divided by a plus 3. Okay, do I have a denominator here with more than one term in it?
Yes.
Yep, what's the first thing I should do to that denominator?
Distribute.
Yep, put your parentheses so you remember to distribute. Okay, so we're going to multiply 4 times a plus 3. Then we're going to multiply a times 6. What symbol is going to go between those two products?
oh, between what two?
So let's do it out. What's 4 times a plus 3?
Oh, 4a plus 12.
Okay, yep, we'll do that out. What's going to go on the other side?
6a
6a. Now what goes between them?
equals.
Equals, that's what I was looking for, equals. Okay. Now we already said what this was, that's 4a plus 12 equals 6a. This one's going to have 2 steps. Okay, what's my next step here?
Subtract 4A, remove that.
Good. Subtract 4A. What will that leave me with on the left-hand side?
2A. That'll leave you with 12.
Yeah, just the 12 and 2A. Okay. Last step. Matt, what's my last step? Divide by 2. Divide by 2. And what do I get for A?
6.
A is 6. Okay, questions on that one? Okay, these are the exact kind of problems you're going to have on the test. Exactly like that. They're not that bad if you know how to do them.
Hey guys, on the other side of the board, I just put, I just kind of gave a little bit more detailed explanation of when the denominator has more than one term. It's kind of like what we talked about. We said put parentheses around the denominator with more than one term, and I rewrote it here. Cross multiply. You have to use the distributive property, right? Because for that denominator that is more than one term. That's what I did. Once you get to this spot, right? Use those steps we talked about the first week of academics to solve equations, right? The SAM method. Simplify, right? So that would mean do your distributive property, right? Then add and subtract, then multiply or divide.
Okay, so let's look at example 2C.
So guys, just take a minute or just take 30 seconds, and on your paper, I just want you to write out the first. I don't want you to solve it yet, but just write it out. Write out what the equation would look like when you cross multiply.
All right. So when you have a proportion and you have more than one term in the denominator, what did we say the first thing you got to do is? Somebody raise your hand. Tell me the first thing you have to do.
No.
It's up on the board. Mr. Roy put it on the board for us. Savon?
You have to put A minus 4 in parentheses.
Perfect. Put A minus 4 in parentheses. Okay. What's that for? That's to remind us to use what property? Yep. Distributive. Okay. Now we're going to multiply 3 times A. And we're going to multiply negative 5 times A minus 4. Okay, let's start with 3 times A.
3A.
That's 3A. Good. Okay. Now the other one, we have negative 5. Okay, we'll do it in 2 steps. 8 times A minus 4. Okay, so Ben, what's negative 5 times A? And what's negative 5 times negative 4? Negative times negative is positive. Okay, what's my next step? Next step, Victoria? Yep, we're going to add 5A. Add 5A. Okay, negative 5A plus 5A cancels out. Okay, Dominic, what's 5A plus 3A?
8A.
8A, good. On the right-hand side, all I have left is 20. Okay, what's my last step?
You divide by 8.
How the heck in the world?
Divide by
8,
8,
and then you get,
divide by 8.
yeah, and then you get that in simple.
Don't understand this, man.
Okay. So A equals
20 over
20 over 8,
But then we simplify.
which can simplify to what?
5 over 2.
Okay.
5 over 2.
So I had somebody say 10 over 4, that's correct. Then you go one more step,
5 over 2.
5 over 2.
I said,
Okay, my suggestion, okay, this is the last one I'm doing, we have to move on. If you didn't understand those 3, okay, go back online, watch them, keep watching them, till you finally get it, because you'll see all the steps over and over. Okay? So take a look, and hopefully I'll get the video online for you this afternoon. Okay. Next thing we're going to do is look at a proportion. Okay? This time it's going to be a word problem. So now we still have to solve the proportion, but now we got to set it up first. So this is one step harder.
You have to write this whole thing down.
Yep, this is the example.
Like, wait until, like, you write it down. Wait a second, we have to write the whole thing
Yep.
down?
Yep, so let me read it. Let me read it to you first.
But you're gonna have to wait, 'cause
It says a recipe for 3.5 dozen muffins, okay, requires 700 grams of flour. Okay? So if you want to make 3.5 dozen muffins, you need 700 grams of flour.
A dozen is 6, right?
How many dozen muffins can we make with 800 grams of flour? Okay? Okay, so I'm going to show you how you set this up. Okay, you are going to have one of these on the test. You're going to set up a proportion. Okay, so start by writing down an equal sign. Put in your fraction line for your proportion. And we're going to have 4 things we need to fill in. Okay? You're going to have to fill in something on the top in each and on the bottom in each. Okay? And what we're going to do is we're going to set it up so that we're comparing the same thing on each side of the proportion. So on the left proportion, I'm going to put how many dozen in the top. And I'm going to do the same thing on the right. How many dozen on the top. In the bottom, the other thing I'm comparing is flour. So remember, ratio compares 2 things. We did this at the beginning. We did water and flour. This time we're doing dozens and flour. Same idea. So we're going to put flour.
If they said muffins, would they be wrong?
This is muffins.
Well, we're not going to be calculating how many muffins. We're going to be calculating how many dozen. So so in this case, the number of muffins, we're measuring it in dozens. So we might get 4 dozen muffins. If you wanted to convert that to how many muffins, then you multiply by 12. That tells you how many muffins you'd have. Okay? So this is how you set it up. On the left, dozens in the top, flour in the bottom. On the right, dozen in the top, flour in the bottom. Now we're going to fill in the numbers we know. Look how many numbers we have. 1, 2, 3. We're only going to be missing 1 out of the 4 things we need.
So guys, next to that, next one Mr. Hager has that first dozen, right? Next one Mr. Hager has that first dozen. What number should go there? Who can tell me by raising their hand? What number should go with that first dozen? Isaiah?
3.5.
Yeah, how can you put it if you want to? 3.5. Cool, right? Under that, right, so the 3.5 dozen, right, how many grams of flour does he need to make those 3.5 dozen? Somebody tell me by raising their hand. 700, good, Spencer. Other side, on the top, that dozen. What's that dozen gonna be? You can tell me by raising their hand. It's gonna get to be the tricky part. Spencer. D for dozen, X doesn't matter, right? It could be any kind of, any letter you want. And then below that, it's going to be the what? The 800, right? All we're doing, keeping the same units in the same spot, right? So for any old problem, say, I'm just going to step in here for a second.
5 times 800.
Right? So guys, up on the board, for any kind of problem, right? Unit number 1, doesn't matter what it is. You got to compare it to unit number 2. Same thing on the other side. If you chose unit number 1, all right, on the other side, it better be in the same spot. It better be on the top. Same thing here. Whenever you're saying unit for it could be whatever. miles, it could be trees, it could be whatever. Whatever you're comparing on one side, make sure it's not on the same spot on the other side. That's important, all right?
Okay, so there's our proportion. 3.5 dozen requires 700 grams. How many dozen will require 800? That's how you set up your proportion. And how are we going to solve that? What do we do? Yep.
Cross multiply,
Cross multiply. Okay. What's 700 times x?
700x.
700x. Okay. And then I also have to cross multiply 3.5.
2,800.
Is that what it comes out to?
Yeah.
2,800? Everyone see how you type that in? It's just 3.5 times 800. 2,800.
And then you divide by 700.
Now to get x by itself, you're going to divide by 700. Divide by 700.
And you get 4 dozen.
You get 4.
Yeah, 2,800 divided by 700 is 4 dozen.
2,800 muffins?
So if you used 800 grams of flour, you could make 4 dozen.
How many donuts is that, guys? Anybody know?
48.
48, right? It's 12 and a dozen.
Yeah, I didn't count Parker's.
Dominic has had a good question back here. He said, Mr. Roy, guys, hold on. He said, Mr. Roy, how do I know which one to cross multiply first? It doesn't matter. You can go either way. You can go left to right, all right? You can go right to left. Either way, it doesn't matter.
You go up and down.
Keep walking down. Sorry. Not this time.
Okay, and when you set up these proportions, there's more than one way to do it. Notice how Mr. Roy wrote unit 1, unit 2. You can let unit 1 be whatever unit you want. You can let unit 2 be whatever unit you want. Just set it up the same way on each side. Okay? So how could we set this one up? What could we do to set this one up? Isaiah?
Whoa, set it up?
Yeah, you don't have to give me the answer. I just want to know how we set it up.
2.5, or 2.5 dozen, whatever you want to do.
Okay, so 2.5 dozen, yep.
And then 400 grams of flour,
Where does that go?
the bottom.
Good. Okay, so 2.5 dozen requires 400 grams.
And then X or D, whatever.
Yep, X dozen requires how much?
600.
In this case, 600. So we put dozens over grams, dozens over grams. Anybody give me a different proportion that would still, it would be perfectly fine if you set it up that way. There's many, many ways, so we don't have to go through them all, but let's just try one more. Savon?
You can switch it around.
Yep, how would you switch it?
X is up over here instead, actually.
Okay, so yeah, you could switch what's on the left and the right. Sure. X over 600.
400 on top and 2.5.
Okay, so go ahead, tell me what you're going to say.
400,
Okay,
2.5
over 2.5 equals what?
equals 600 and over X.
Over X. So this time he put grams over dozens equals grams over dozens. That's going to work perfect. The reason, look at when you cross multiply. You're multiplying 2.5 times 600. What about in the bottom one? Same thing. Okay, that's one of them.
See, could you do it
Let's
the other way?
check the other one. You're doing 400 times X. What are you doing in the bottom one? 400 times X. Okay? There's 2 different ways to set up this problem. Okay, and there's many more.
What if you switch like the 2.5 and the 400? So
Okay,
you
so
do
tell me what
2.5
you're thinking.
Try 2.5 over 400, and then 600 over X.
Okay, that we can't do.
Oh, no bueno.
No. Okay, the reason we can't do this one is because you put dozens in the top, you put grams in the bottom. On this side, though, you switched it. You put the grams in the top, and you put dozens in the bottom.
But would it still work?
No, because now you'd be multiplying X times 2.5, not X times 400. Okay, so this This way wouldn't work. But that's important to see because a lot of people try to do this on the test and it doesn't work. Okay? If you've got to do dozens over grams on the left, you've got to do dozens over grams on the right. Okay? So let's finish it up. Okay. What's 400 times, we'll just use the top one, 400 times x. And then 600 times 2.5 gives me what? 1,500.
1,500. Then you divide by 400.
Divide by 400.
Then you get 3.75.
What do you get? 3.75?
Yeah.
And what should be my dozen? So I can make like 3 3/4 dozens. 3.75 dozen.
Oh my God.
Okay? Let me give you one more that's going to be similar to what's on the test tomorrow. Let's say that I had a car. Okay?
Mr. Hager, you want to give me, Mr. Hager, you want to give me a worksheet? We can do that one right now together so they all have it written down?
Is it on that worksheet?
Yeah, there's one, not the exact one. Yeah, it's on there. Number,
Is that our homework?
yeah, number 5, Mr. Hager. I did it in memory of you.
All right.
I did it in memory of you.
In honor, I should say.
In memory.
It makes it.
Yeah, it sounds like
He survived the hike. He didn't die on the
Are you
hike.
sure?
He made it.
All right. So when you look at number 5.
Guys, we're looking at number 5 on the homework.
Okay. First, in number 5, what are the two things we're using? What kind of units?
Feet and hours.
Feet and hours. Okay. We're not using dozens and grams anymore. We're using feet and hours. Okay. So now we have to decide which unit goes in the top, which one's going to go in the bottom. Okay. On the left-hand side, what unit do we want in the top? Feet, sure. What unit is going to go in the bottom?
Hours.
Hours.
Do you actually have it?
All right, so on the left-hand side, we decided to put feet in the top, hours in the bottom. What has to go on the top and the right-hand side? Feet. What has to go in the bottom?
Hours.
Hours.
That's what.
Okay. What number is going to go in the top on the left?
3,000
3,000.
over 3.
So 3,000 feet, how many hours?
3 hours.
3 hours.
5,000 feet
Now it says, 5,000 feet
over X hours.
over X hours. There's your proportion you need to solve. Okay, we're not going to go through and give you the answer, but there's the setup. Okay, so for homework tonight, you're going to do that worksheet. Okay, that's your homework tonight.
I thought it was going to be the